All right, so trying to apply some theorems to specific problems. Again, you should know each of the different ways that you can show that two triangles are congruent, not just from 5.6, but the other sections as well. So for each of these exercises or problems, it says decide whether enough information is given to prove the triangles are congruent. If so, state which theorem you use. You should probably just use the abbreviations. So on number 1, triangle GHK, you want to know if that's congruent to triangle JKH. So here's what we have. These two angles in triangle GHK are congruent to these two angles, and then these two sides are congruent. So you could specifically say yes, because if you trace it out, angle, angle, side. Angle, angle, side. You could also do this. HK is congruent with itself, so it would still be angle, angle, side if you use these two angles and this side. And then it would be these two angles and this side. So either way, it would work. And then on number 2, triangle ABC is congruent to triangle DEC. You have to make sure everything matches up as well. A corresponds with D, B corresponds with E, and then C corresponds with itself. Those two triangles would be congruent by angle, side angle. The side is included between the two angles. So yes, those two triangles are congruent by angle, side angle. And then on number 3, here's where it gets a little bit more complex. You want to know if triangle JKL, so I'm going to trace that out right here using a different color so you can see a little bit better. That's when I pencil roll across the paper. The triangle JKL, which is right here, you want to know if that's congruent with triangle MLK. Right here, this blue triangle. So is the orange triangle congruent with the blue triangle? If you're not sure, here's what you might need to do. Like break apart the triangles. Here's triangle JKL. I know that angle J is congruent to, and let me erase that because this is actually KLM. These two angles are congruent, and it's given that these two parts, MN and JN, are congruent, but if you're given those two sides are congruent, so if all that you're given is MN is congruent to JN, that's not even this full side or this full side. You can't assume that NK is congruent to NL, and then that's all that we're given. So only an angle in one triangle is congruent to an angle in the second triangle. That's none of the theorem, so no. And then lastly, on number 4, even though these are right angles here, angle T and angle W are right angles, a lot of people might think, well, then it has to be hypotenuse leg, but we only have the hypotenuse congruent, which is true, but you're also given angle S is congruent to angle V. So if you take a look at the information that's given, this is an angle, even though it's a right angle, it's still an angle that's congruent with this angle. Angle, angle, side, and then angle, angle, side. So yes, even though they're right angles, it doesn't have to be. The two triangles have to be congruent by hypotenuse leg. They can be congruent by angle, angle, side as well. And in this case, they actually are. And then looking at a couple of other examples, decide whether you can use the given information to prove that triangle LMN. So I would just draw a triangle if I were you to make things easier to see. LMN like that. And then triangle PQR would look like this. So if angle M is congruent to angle Q, and then angle N is congruent to angle R, and then NL is congruent to PR or RP, is that enough information to determine that the triangles are congruent? And then the answer should be yes, specifically by angle, angle, side. The side is not included between the two angles, nor is side PR included between angles Q and R, but they're still congruent specifically by angle, angle, side. That's my reasoning. That's good enough. And then you could do something similar with number 6 as well.